Good day. This is our second lesson for term number 2, Matter and Materials. And we looked at the first unit, which was atoms. Okay, in our first lesson, we looked at unit number 1, which covered the atom. And we know that the atom is the smallest particle that make up matter. Okay, and under atoms we have looked at particles. Okay, so today we are going to focus on elements and compounds. Okay, so we are going to look at elements and compounds, and under compounds we are going to look at forces between particles and decomposition. That is what we are going to cover in this second lesson for term number 2. Okay, remember to have your periodic table and to know your elements from element number 1 to element number 20. Okay, so let us go to 1.2, and we are going to start with elements. Okay, this is on your page 111. Let me see, do I need to zoom down? Maybe just a little bit. Okay, I think that it should be okay. Okay, so we are going to start with elements. So just a recap on what we covered on atoms. We said that atoms are made out of small particles, right? And elements are made out of atoms. And we said for each and every element, it has got different atoms. Okay, but the atoms in one element are the same. And we said that our atoms, we find them in the periodic table. You remember that? You remember we said, I just want to find the periodic table. We said our our elements, we find them in the periodic table of elements. And we said for now, it's our grade, we just need to know element number 1, element number 2, element number 3, all the way up to element number 20. That is it that we need to know for our grade currently. Okay, so they say that elements consist of one kind of atom. They repeat what we have learned yesterday. Each atom has a certain number of neutrons, protons, and electrons. So the atom, remember the drawing for the atom, we have the neutrons and protons in the center, which is the nucleus. And that together, the neutrons and protons together, we call them nucleons, and they make up the mass of the atom. And then we have electrons, which are on the outer part of the nucleus. They are surrounding the nucleus, and the electrons, they make up the volume of the element. Okay, and they are negatively charged. This gives each material its own unique properties. For example, carbon, remember carbon is the element in the periodic table, and it is number 6 if you can recall. You see, it is number 6 in the periodic table. That's your carbon. Okay, okay, so they say that, for example, carbon, sodium is also an element in the periodic table. Let's go to the periodic table. This is sodium, it's element number 11. Okay, so sodium is the element in the periodic table. Sorry about that. Let's go back to our textbook. For example, carbon and sodium, gold is also an element in the periodic table. Did you know that? Where is gold? Gold is AU. Gold is number, no, that is not gold. That is silver, that is silver, that is silver. Just give me a second. I will find gold for you in the periodic table. There it is, gold. You see gold? Element number 79 in the periodic table, and the symbol is AU. Okay. And silver, the symbol is Ag. So all these things, aluminium, iron, they are elements in the periodic table. Wow, that's something new for you. Okay, let's go back. They say, for example, carbon, sodium, gold, and they have different, or they have unique properties. There are a limited number of known elements. All these elements are indicated on the periodic table. From these elements, millions of compounds are formed. So elements as well forms compounds. Okay. Remember, particles, subparticles, they form a atom, and the atoms, they form elements. And now we learn something new, that elements form compounds. Okay, so now let's learn what is the definition of an element, so that we can know how to explain an element. An element is a substance that cannot be broken down into two or more materials by chemical means. Remember, we discussed this in our first lesson, that an element cannot be broken down. So the definition, an element is a substance that cannot be broken down into two or more materials by chemical means. You need to know this definition. Each element has a specific place on the periodic table. See, each and every element is sitting on the periodic table, and it is on its own. Okay, so you will not find two or three elements sharing a place in a periodic table. Each and every element has got its place. Okay. Each element has a specific place on the periodic table. The periodic table consists of vertical columns known as groups. Okay, let's look at the periodic table. Vertical column, this column, this is group 1. You see it's written there at the top. The next vertical column, this is group 2. The next vertical column, it's this one. This is group 3. The next one is group 4, all the way until we have group number 18. The vertical columns are groups. Okay. And the periodic table also has got the horizontal rows, which are known as periods. Okay, so let's look at the horizontal row. Okay, this is period number 1 if you're looking horizontally, number 2, number 3, number 4, number 5. You see, so horizontally it's the periods, periodic table, and vertically it's the groups, and the groups are numbered at the top. That's how the periodic table is arranged. Now they tell us that elements are placed in order on the basis of the number of protons in the nucleus. Okay, so the order in which elements follow is based on the number of protons in the nucleus. What does it mean? So let's look at our first element is hydrogen, and it is number 1, which means we have only 1 proton in the nucleus. Okay, and then we look at helium. Helium is number 2. It means we have 2 protons in the nucleus. We look at lithium is number 3. It means we have 3 lithium. It means we have 3 protons in lithium. And we look, let's take for example sulfur. It means we've got 16 protons. Okay, and one thing not to forget, is that always the number of protons is equal to the number of neutrons, okay, for all neutral atoms. And here they say that elements are placed vertically in groups on the basis of the number of electrons in their outermost energy level. Okay, we will explain this energy level further, but they say they are placed vertically in groups on the basis of the electrons in their outermost energy level. Okay, I will explain this to you as we grow with the subject. And they say elements are placed horizontal rows, which means on period, on the basis of the energy level in which the outermost electrons are found. Okay, so elements are placed vertically in groups on the basis of number of electrons in the outermost energy level, and that elements are placed horizontally on the basis of the energy level, okay, in which the outermost electrons are found. Okay, so as we go this way, vertically, they say they are placed both based on the number of electron on the outermost energy level going down. Okay, it's number of electrons on the outermost energy level, but going this way horizontally, they are placed both on the energy level. Okay, this way it's energy level, vertically it's number of electrons in the outermost in the outermost electrons. Okay, now they say that, I don't know if you can still see that. Let's scroll up a little bit. Based on that, conclusions can be drawn about the structure and properties of the element from an element's place on the periodic table. Some atoms do not occur alone. Two atoms can bond together. Okay, so two atoms bond to each other to form a molecule. So if I have two atoms which are the same and they are bonded to each other, which means they are joined to each other. For example, if I have two oxygen atoms bonded to each other, they form an oxygen molecule, which is O2. Okay, which is still an element. If I have same atoms, I still have an element. Although it is a molecule, but it is still an element. All molecules consisting of two identical atoms are called diatomic elements. Okay, they are elements and we call them diatomic elements. It is molecules that consist of the two or more identical atoms. Actually, two identical atoms. They are called diatomic elements. Okay. There are also diatomic molecules that do not necessarily consist of identical atoms, which means we can have a atom of kind A with the atom of kind B joined together. That is still a molecule, but the atoms are not the same. These molecules are known as diatomic compounds. Okay, if it's only two atoms but they are not the same. For example, we have hydrochloric acid. You will see we have hydrogen atom and we have chlorine atom. Then they make a diatomic compound. Okay, so if they are not the same, they make compounds, but if they are the same, they make still an element. I mean the atoms if they are the same. Now they say that there are 7 diatomic elements in the periodic table. Wow, in the periodic table we have diatomic elements. The 7 diatomic elements in the periodic table they come like this. They are diatomic. So we have hydrogen gas, we have nitrogen gas, we have oxygen gas, we have fluorine, we have chlorine, we have bromine, and we have iodine. Okay, so let's look at them in the periodic table. The diatomic, it is hydrogen, it is nitrogen, it is oxygen, it is fluorine, it is chlorine. Yes, it is chlorine, and it is bromine. Let me look at the last two in our textbook. And iodine, the last one. Let's look at the iodine. Here is the iodine. You see that? So our diatomic molecules are hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. Okay, so you see them in the periodic table. You must know that they are diatomic molecules because they have two atoms that are identical or that are the same. Okay, so please know these diatomic elements. And now we are done with elements. We move to compounds. Okay, so we said that compounds are formed if two atoms of different type they join together. Two or more they join together. Okay, so they say that elements can react with each other chemically to form compounds. Okay, let's see how does that happen. So we have element, which is the helium. You see it's not joined to anything. You see these atoms are not joined to anything, therefore it is an element. And then we have another element, which is oxygen. We have two atoms that are the same of oxygen, so therefore it's still an element. But if you look here, we have three atoms that are the same, but they are joined to one atom that is different to them. So in that case, we have a compound, and this compound is ammonia. These three white atoms are the atoms of hydrogen, and this blue ball, it is a nitrogen atom. So when we write ammonia, we write it as NH3. N is the blue one for nitrogen, and H3 is for the white one for hydrogen. They are joined together to form a compound ammonia. Okay, now when we look at materials, we have pure materials, okay, which have the particles of the same. Pure materials, the particles are the same. So pure materials are divided into two categories. We have elements and we have compounds. Okay, we have elements and we have compounds. Elements, we know them, they are in the periodic table. Materials, and they are materials that cannot be broken down into simpler parts by chemical means. So example, you can take any element that you see in the periodic table. And we have compounds. Compounds, they are made of two or more elements. So it's materials that can be broken down into simpler parts by chemical means. So compounds can be broken down into simpler parts by chemical means. And the example of compounds, it's water. Water, we write it as H2O, which means we've got two atoms of hydrogen and one atom of oxygen joined together. Okay, and we have table salt, which is sodium chloride. So we've got two atoms, one atom of sodium and one atom of chlorine. Okay, all these atoms, we find them as elements in the periodic table. And we have carbon dioxide, which is CO2, which means it's two atoms of oxygen joined to the carbon, okay, that makes compounds, okay. A compound is a material that consists of atom of two or more different elements, okay. Please note, different elements that are chemically bonded together. Bonded means joined together. Let's define a compound again. A compound is a material that consists of atoms of two or more different elements chemically bonded together. Example of compounds are water, ammonia. So now you see the chemical formula of ammonia, the one that we saw at the top there. We saw the drawing of ammonia. You see 3 atoms of hydrogen and 1 atom of nitrogen. Let's go back and see that. So that is ammonia, example of a compound. Table salt, which is sodium chloride. And the properties of compounds differ from the properties of elements. The properties of compound differ from the properties of elements that is made up of. So which means that the properties of ammonia are not the same as the properties of nitrogen, or are not the same as properties of hydrogen. Okay, the properties of a compound, they are different from the elements that it is made up of. Compounds can be broken down into simpler materials again by heating or electrolysis. You will learn what is electrolysis. The simpler materials are the original elements of which it was made of. So now they explain what is simpler materials. They say compounds can be broken down into simpler materials again by heating or electrolysis. Then they say the simpler materials are the original elements of which it was made of. For example, this compound is water. So if I break it down to simpler materials, my simpler materials are going to be hydrogen and oxygen. Okay, so which means I can break down water into hydrogen and oxygen, or I can break down ammonia into nitrogen and hydrogen, or I can break down salt into sodium and chlorine. Okay, those are the simpler materials. So what is electrolysis? Because they say compounds, we can break them down by heating. We know what is heating, or electrolysis. So what is electrolysis? Electrolysis is the process whereby an electrical current is sent through a solution to break it down. Okay, so we break down a solution using electrical current. That is electrolysis. Electrolysis is the process whereby electrical current is sent through a solution to break it down. Okay, so let us continue with compounds. They say, however, compounds are also pure because the particles are all the same. Okay, so compounds are also pure substances. The elements that the compound consists of always bond in the same ratio. We will explain this when we get there. All water molecules are H2O and can never be HO or HO2. That is what they mean by bonding in the same ratio. So you will always find water to be H2O. It works like a puzzle. The pieces can only fit in a certain way and pieces cannot be changed. So you see they took the molecule of water, which is 2 hydrogen atoms and 1 oxygen atom. So you see this is a piece of puzzle, oxygen atom, 2 opening slots, and only this hydrogen can fit here and that hydrogen can fit there. That is why they say the elements of the compound, they always bond in the same ratio. Okay, so now you understand what do they mean. And let's look at the quick facts there. Just a second. They say 118 elements are known to us. Only 96 of these elements are found in nature. Let's see in the periodic table how much do we have. We have 103 here in the periodic table. Okay, they say 118 elements are known to us and only 96 of these are found in nature. These elements combine and form millions of other compounds. So elements are building blocks for compounds. Okay. Now let's look at the forces between the particles. Remember, when the compounds form, it means it is an atom joined to another atom. So there are forces between these joints, okay, or between these bonds. When atoms are close together to each other, attractive forces exist between the atoms. The attractive forces keep the atoms together so a compound can form. These attractive forces between the atoms are usually very strong. A chemical bond is the force that holds atoms together. Now we know what is this force now. It is a chemical bond. Forces between particles are chemical bonds. So they explain a chemical bond is the force that holds atoms together. A chemical compound is the material that is referred to, for example, H2O. So there is a bond between hydrogen and oxygen, and that is the chemical bond. An example of a compound is water. It consists of 2 hydrogen atoms and 1 oxygen atom that have bonded together. The formula is H2O. Another example is oxygen gas that we inhale. Okay, it consists of 2 oxygen atoms that have bonded together. That is a diatomic element. And the formula is O2. You see the atoms are the same. Sometimes many atoms can bond together to form large structure. For example, carbon can be in the form of a crystal, for example, to form diamond. Okay, so we can have a large structure made out of many bonds. Okay, they give us an interesting fact that we use daily but we don't know. Another example of carbon is graphite. Graphite is the lead in pencil. This thing inside the pencil, okay, that you use to write, it is graphite and it is carbon. Okay, so we have examples. We have water, where we have 2 hydrogen and 1 oxygen atom. We have a oxygen, which is a diatomic element. We have 2 atoms of the same, and we have sulfur 8, which we have 8 sulfur atoms. Okay, and we have nitrogen gas, 2 nitrogen atoms, and we have carbon dioxide, 1 carbon and 2 oxygen joined together. Please take note that with the compounds, they are joined together. And we have CH4, which is methane. We have 4 hydrogen joined to a carbon atom. Attractive forces also exist between molecules. These attractive forces between molecules are usually fairly weak. Okay, we only become aware of water vapor when millions of molecules come together to form a drop of water. Sugar is a crystal, but when the molecules dissolve in water, we can no longer see it. even though we can still taste it. Repelling forces can exist between the particles when it is pushed close together. Okay, that is just additional information. So before we get to the exercise, I want us to go to page, please, I don't want to skip, page 117. Now we've learned about the forces between compounds. Then we can go to page 117 and we look at decomposition. Okay, so they say now compounds can be broken down or decomposed into smaller parts, we said, by heating or by electrolysis. And we know by now that electrolysis is when we add electric current in a solution to break down the compound. Compounds can be separated by chemical means. For a compound to decompose, energy must be added. So we add. So a chemical reaction which breaks down a compound into simpler product is called decomposition. Okay, so what is decomposition? Decomposition is a chemical reaction which breaks down a compound into simpler products or simpler material. It is called decomposition reaction. I won't go through the example now. I want us to go straight to page 118 and we look at the electrode. They say it's just a fact. The electrode closest to the positive pole of the battery is called anode, and the electrode closest to the negative pole of the battery is called cathode. Okay, so for now, don't stress about this until we do the practical. You will know what is an anode and the cathode. I will explain when we get to that part. So I just want us to wrap up the compounds section. Okay, so they say copper chloride, which is a compound, is made out of 1 atom of copper and 2 atoms of chlorine. Can be broken down by electrolysis. We know now what is electrolysis, into simpler materials, for example, copper and chlorine gas. More example of decomposition reactions. Water can be broken down by electrolysis into hydrogen and oxygen. Potassium permanganate, which is KMnO4. It's the potassium atom, 1 potassium atom, 1 manganese atom, and 4 oxygen atoms can be heated to produce oxygen. The gas that is released in a practical investigation can be tested. A glowing wooden splint can be held in the gas. If the wooden splint catches the fire, the gas is oxygen. So you can investigate and test what gas is released. Okay, so in this lesson we will end here with compounds and the different methods that we use to break down the compounds. Okay, we talk of heating, electrolysis, and we explained what is a decomposition. Okay, so now I want you to go to page page, where does this start? I want us to go to the exercise. I think it's exercise number 10 is from your textbook, starting from page 114 if I'm not mistaken. Let's see. Now you start at the bottom of page 113, exercise 10, from number 1 all the way to page 116, number 8.4, number 1 to number 8.4. Okay, that is the exercise that I want you to complete on the elements and compounds. Okay, thank you.